Waste-gated turbochargers gate a portion of the exhaust gas around the turbocharger turbine wheel, and the exhaust energy is wasted. That is, the exhaust energy is not used by the turbocharger compressor wheel to pump intake air into the engine. A waste-gated turbocharger is used for better low engine speed performance and control of high engine speed boost. The VGT bearing housings are oil lubricated. The major components of the variable geometry turbocharger are the compressor and housing, the turbine and housing, VG actuator, either pneumatic or electric, nozzle ring, shroud plate, yoke mechanism, turbo speed sensor, turbo compressor inlet temperature sensor, and VGT position sensor, electronically actuated VGTs only. The sliding nozzle inside of the turbine housing adjusts to vary the turbine volute exit area. This action creates the increased back pressure in the exhaust manifold to force some of the exhaust gas through the EGR valve when it opens. The sliding nozzle is adjusted by the VG actuator. With the nozzle ring fully closed, the turbine volute exit area is at its minimum. This creates the maximum exhaust manifold pressure. Turbocharger shaft speed and boost pressure are at their highest. With the nozzle ring in the fully open position, the turbine volute exit area is at its maximum. This creates the minimum exhaust manifold pressure. Turbocharger shaft speed and boost are at their lowest. The sliding nozzle position is infinitely variable between open and closed, with either pneumatic or electric actuation. The external components of the EGR valve include exhaust gas inlet, electric motor, position sensor, heat shield, coolant ports, exhaust gas outlet, actuator cover, and poppet valve. The outwardly opening poppet valve opens into the exhaust manifold and is controlled by a high-speed electric motor with a gear reduction system. The position sensor on the valve signals the ECM as to the actual position of the EGR valve. The ECM constantly adjusts the valve lift through the use of the motor and gear reduction to produce the necessary EGR flow. As we stated earlier, by cooling the recirculated exhaust gas, the overall temperature of the charge air will be reduced, thereby reducing the peak combustion temperature and reducing NOx formation. The coolant and EGR gases enter the cooler on the same end of the cooler and flow parallel to each other. As the gas enters the cooler, a diffuser ensures even distribution. The even distribution is the only way to achieve the necessary cooling of the gas. A method of thoroughly mixing the exhaust gas and fresh air is required. This is accomplished in the EGR mixer. The mixer also ensures that the charge air mixture is consistent for all cylinders. The Venturi-style mixer, also known as the ejector on some engine families, creates a pressure drop in the Venturi throat. The fresh air and the recirculated exhaust gas combine just inside the Venturi throat. The pressure drop in the Venturi helps to draw more exhaust gas into the system. The Venturi does cause a small efficiency loss due to the energy needed to move the air through the small diameter of the throat. From the mixer, the charge air travels on to the intake manifold. The fluted-style mixer mixes the recirculated exhaust gas and fresh air with a minimal amount of pressure drop. This style mixer is more desirable because it does not have the small loss of efficiency that is seen on the Venturi-style mixer. However, it can only be used on engines that do not need assistance from the intake mixer to get the necessary EGR flow rate. Now that we have discussed each component of the EGR system,